Maker snack.
Set up for CircuitPython programming with the Circuit Playground Express Bluefruit edition. Follow along guide at bit.ly/cpxb-setup. Hello programmers, so we are going to set up a Circuit Playground Express Bluefruit edition so that we can program in CircuitPython, and we're going to set up the Moo editor to use that as well. A follow-along document is at bit.ly/cpxb-setup. And if you type in that address, you'll go to this Google Doc that you see right here. A quick note to show you right from the start. Mac users, if you are working with a CPXB, every now and then certain actions will present you with this message here, disk not ejected properly. Never worry about that message if it shows up. It's just something that happens when using the CPXB on your Mac. Now let's first make sure that our Circuit Playground Express Bluefruit is working. So why don't you plug in one end of your USB cable into your computer, your Mac or your PC, and plug the other end into the CPXB. When you do this on a new CPXB, what you should see is this rainbow pattern. You'll also see a little green light on that indicates that the board is getting power. And always make sure that your micro USB cable is a data cable, not just a charge cable. Otherwise things won't work. Now we're going to download the version of CircuitPython for our board. So you can copy this URL. This brings you to the Adafruit Learn Guide for the Circuit Playground Bluefruit to install or update CircuitPython. And scroll down the page until you see this green link that says download the latest version of CircuitPython for this board via circuitpython.org. From this page, click on the download.uf2 file now. Remember where you save that. I saved mine to the desktop. Now, before I copy this file over, I'm going to double click on the center reset button in the middle of my CPXB. What that's going to do is it's going to turn all of the lights green, and my Circuit Playground is going to be mounted to my computer almost as if I plugged in a USB drive. It'll have the name cplaybt boot, and then I can click on this UF2 file, drag it into cplaybt boot, and that will copy over the latest version of CircuitPython. Remember, we're just clicking and dragging from the desktop into cplaybt boot. Don't double click the UF2 file and try to open it up. Now this is going to unmount cplay boot, and if you're a Mac user, you'll get a message about the disk not being ejected properly. Just ignore the message. Now return to the installation document and scroll down to the area that says update the CircuitPython libraries on your CPXB. Grab this URL, copy it, return to the web, and paste it in. This will take you to Adafruit's page for the CircuitPython libraries. Just scroll down this page until you see the green link that says click here for the latest Adafruit CircuitPython library bundle release. The first button you click on should match the UF2 file that you downloaded. So mine was version 5. I'm going to download bundle version 5 right here, save that to my desktop. And once the zip file is done, I'm going to return to the desktop and double click on zip. The zip file is just a compressed version of the folder with all the files inside of it. Now here's one word of caution. Some of our Windows users have something called WinZip that pops up and asks you to register. This is just some bloatware that was installed on your PC, probably when you bought it. You don't need this, so you should delete it. So Windows users, if you see this, what you should do is uninstall the WinZip application. You can Google on how to do that. Follow the instructions on a page like this, and then you should be able to right-click and extract your zip file. So the zip file is going to create a folder with the same name, and we can actually delete the .zip file. We don't need that anymore. Now, when I double-click inside of this to look at what's inside of that folder, I see a bunch of things, some example files you can explore later on your own, and I also see this lib file. Now, inside the lib file, if I expand it, I see a ton of other different files here. Now, all of the files that we see actually extend the capabilities of CircuitPython so that they can do lots of different things with lots of different hardware. Because out of the box, Python doesn't necessarily know about the Circuit Playground Express and all of the things that you can do on the CPX. So these library files allow us to extend Python. Now, we don't need all of those files, and in fact, everything in this lib folder won't fit on our device, but we do need a subset of this, and we're going to need it to be called lib. Now I'm going to rename my lib folder lib-complete, just so that I know where all of my original files are. And you might have to right-click on this folder to get the rename option. And now what I'm going to do is I'm going to create another lib folder that's going to be an empty one at the same level. So if I just go under File here and I say New Folder, this will create a new folder. I'm going to name it lib, and this is where I'm going to put the exact files I need for my CPX. Now what I'm going to do is I'm going to double-click on lib complete to show all of my different files here that I just downloaded. And now I'm going to open up another window next to it, and I'm going to navigate over to that empty lib folder that I just created. And what I'm going to do is I'm going to copy files from this complete folder into the lib folder. And I'm going to drag a certain set of files, or actually I shouldn't say drag, I'm going to copy a certain set of files from lib complete into lib. And the files that I need, I've actually got listed in our CircuitPython setup doc. So if we scroll down, we can see the names of them here, or here's a screenshot of them. So you want a folder called BLE, Bluefruit Connect, Bus Device, Circuit Playground, and Fancy LED. So I'm going to grab the 5 folders first. I've positioned these 2 folders on the desktop so that I can drag from one into another and still look at the file names in the Google Doc behind. So now I'm going to scroll to find Adafruit_BLE. I'm going to hold down the Command key on my Mac. On Windows, I think it's the Control key. While I'm holding down that key, I'm going to click on the next folder, Adafruit_Bluefruit_Connect. Keep holding down Command. Click on Adafruit Bus Device. Click on Adafruit Circuit Playground. Click on Adafruit Fancy LED. And then I'm going to copy. So I'm going to do a Command-C, or on Windows, a Control-C. And when I click over into my empty lib folder here, I'm just going to paste in with a Command V on the Mac, Control V in Windows, and this is going to make a copy of just those files that I've highlighted. And now I'm just going to click on the last 3 files here. So without touching any keys on the keyboard, I'm going to click on this file here that says Adafruit_LIS3DH. Once I've clicked to highlight it, I'm going to hold down either my Command or Control key on Windows, Command on the Mac. I'm going to scroll down and I'm going to find at the very end, I'll see NeoPixel, MPY, keep holding down Control or Command, and Simple IO. Then I'm going to copy with a Command-C or Control-C. I'm going to head over to the lib folder and I'm going to paste these last 3 files in there. Now I've got everything I need in my lib folder, so I can copy this folder over to my Circuit Playground Express, and I'll be ready to work with Python. And now make sure that your Circuit Playground Express is plugged in. Double-click that reset button right in the middle. You'll see the green ring show up again. Now find your lib folder that you just copied those files into and drag that whole folder right into cplayBtboot. It'll copy the files over for you. If it asks to replace them, just say it's okay to replace them. Then what I'm going to do is I'm going to press the reset button one more time. On the Mac, it's going to close the open window because we just ejected the cplayboot device. But you'll see now, if you open another window and scroll, that now it's called CircuitPy. If you click on CircuitPy, you should see the files that you've copied over in there. Why don't you go ahead and do that and just make sure that you've got everything in your lib folder. It looks good. It's got those files that you want. And if it's got that, then we're ready to install the Moo editor and we'll be ready to code. So in the same way that Excel lets us work with spreadsheets and Word lets us work with documents, Moo is going to let us create Python programs. Now Moo is free. You can find it at the website codewith.moo. I'm going to click on download. Now be careful. Some students in class were clicking on this alpha stuff. That's not what you want. If you have Windows, you want to click on 64-bit. If you have Mac, you want to click on download. So I'm going to click on download and I'm going to save it to the desktop. So after it saves, I'm going to head over to the desktop. I'm going to double click on my DMG. You'll have an equivalent that you can do for Windows as well. And the installation should be pretty standard if you've installed stuff on your computer before. So on the Mac, what you get is on the left-hand side an icon that you're supposed to drag over into the applications folder. Do. Now you want to be a little bit careful here. I noticed some students in class were making a mistake where they were launching Moo by double clicking on this big icon. That's not what you want to do. You want to click and drag from the Moo editor into applications, and I'll speed this video up to the end of the install. And what happens once this is copied over is it's put a copy of the Moo editor in my applications folder. So again, do not double click on Moo editor. In fact, what I'm going to do is I'm going to close this window because I don't need it anymore. And I'm going to throw away the DMG file because I don't need that anymore either. That's just my installation file. So now if I go over and I click on my applications folder, I can see I've got all my apps in here. But if I type in Moo, I can see I've got Moo editor here. And what I'm also going to do is I like to put things in my dock. So for Mac users, feel free to go ahead and do this. I'm just going to drag my Moo editor right there. So now I'm going to launch Moo for the first time. I'm just clicking on it in the dock. You'll get a message maybe that says you've downloaded it from the internet. You sure you want to open? I'll click open. Now the first time that you launch Moo, it's going to ask you to select the mode. Click on Adafruit Circuit Python and click OK. Then in the lower right hand corner it'll say Adafruit to confirm you're all set up. I'm going to expand my window and ready to write code. Just to make sure that everything is working fine on our CPX, what we'll do is we'll type a little bit of code in here. So why don't we type in, and I'm going to get rid of this first line here. So when you have a hashtag in here, this is a comment. It says essentially ignore everything on the line after the hashtag. It's a nice way to be able to document your code. I don't necessarily need that though. And what I'm going to do here instead is I'm just going to put in print, and I do an open and close parenthesis for my print statement. And then inside I'm going to type in some text, and that's enclosed inside of a set of double quotes. And I'm going to say, yay, my first Python program, exclamation point. Now, the CPX doesn't have a monitor, so where are we going to see this? Well, if we click on this word here that says serial, what this does is when things execute on the CPS, it sends the results right out here so we can take a look at them. Now, stuff won't be executed until we go ahead and save. So if I click on save here, I'll get a save dialog box. Notice the tab says untitled. That's because I haven't saved my program and given it a name yet. And the little star next to it means, hey, there are unsaved changes that are inside of the Mu editor. So what I'm going to do is I'm going to save this. I am going to click on my Circuit Pi volume to make sure that I'm saving it there. And if you have any of these mounted volumes that say Mu Editor on the side, you can just click the eject icon next to where it says Mu Editor. That's just a remnant of when you were doing the installation. We don't need that anymore. And I'm just going to give this the name code.py, all lowercase, code.py. So that is a file that will execute automatically and right away when you start up your CircuitPython or whenever you save the file again. And watch what happens down here. It says, yay, my first Python program. So that's what I just had to print out. So that's looking good. At this point, we're ready to go through and work on the exercises that I put together. So let me show you where those are. If you go over, so we're done with our setup document here, and the URL is bit.ly/cpxb-student-guide. That's all lowercase, not underscores, they're dashes. You're going to see a bunch of different things that you can have, and that you can do, and I will encourage you to go through this. But again, just to make sure your CPX is working, what we're going to do next is we are going to import 2 of those board files. Essentially, CircuitPython doesn't know immediately, hey, you're using the board that's the Circuit Playground Express, and it also doesn't know that there are any lights on that board. So by saying, hey, import board and import NeoPixel, you're saying extend what you can do, CircuitPython, so that you can communicate with the Circuit Playground Express, the board that's plugged in, and you can make those NeoPixels, which is just another name for the lights on the board, work. Now what we're going to do is we're going to grab this little chunk of code right here. I'm going to highlight it and copy it. I'm going to paste it in here. So what does this say? And again, I describe it in the document, but just to cut to the chase, I am giving a name that I can use to refer to the 10 little lights that can express any color that are on my board. So I'm saying pixels. I could have called this Jennifer or Lighty McLightface, but pixels is a good name. I'll say equals, and then by saying NeoPixels, inside of the NeoPixels here, there is a way for us to create a reference to NeoPixel light. So when you see NeoPixels, just think little lights. And so what we do in here, even though this looks like some gnarly code, just remember, anytime you want to work with the 10 lights on your board, you can copy and paste these 3 lines and you'll be good to go to start your code. So board.neopixel just says, hey, set up on the board here, and it knows that those NeoPixels exist and that's where the lights are. There are 10 of them, so that's what the 10 means. Brightness is 0.5 means put them at half brightness. 1.0 would be full brightness. 0.0 would be no brightness. And auto_right equals true just means whenever I make any changes to the lights, go ahead and apply them immediately. Now again, you don't have to memorize all the bits in here, but just know, now that we have something called pixels, we can go ahead and we can refer to the 10 NeoPixels that are initially set up at half brightness on our board. Now, let's use that name pixels that we just created. So what we're going to do here is we're going to type in pixels, and we're going to use a command called fill. And with fill, I'm going to do an open parenthesis, and I'm going to do another open parenthesis, a close parenthesis, and another close parenthesis in here. And what I'm going to put inside the parenthesis is when you have inside 2 parentheses 3 numbers that are expressed as 0 to 255, 0 to 255, and 0 to 255, those are RGB values. Now, in computing, any color can be expressed through R, G, and B, red, green, and blue, which sounds a little unusual because in elementary school you learned that red, yellow, and blue were the primary colors. But this is one of the more common ways that computers express colors. So what we're going to do is we're going to say 25500. This says make a color which is going to be entirely red, not green, and not blue. Now the tab says code.py, that's our file name, but the star means we have some unsaved changes. So when I click on save, the star is going to go away. It's going to save the file to my CPX, and it's going to immediately execute. So watch when we click save. Boom, the lights all show up in red. How cool. Well, what would happen if we change 255 to 0? Remember we said these were R, G, and B, and we do 255 here for B. And click on save, and Whoa, they turned to blue. So I wonder what would happen if we did red and blue at the same time. So I'm going to change my red back from 0 to 255. I'm going to click on save again, and whoa! Red and blue give you purple. Now you can also Google to find out the different R, G, and B values for different colors. I'll also cover these in future assignments, but you're all set up. Hopefully you're feeling really good about what you've done with your CPX. Keep at it.